Hello, this is your review video for Unit 2. And so first we're going to go through these limits. This first one, you want to notice that this is the definition of a derivative. So you don't want to really do this as a limit. You want to realize the pattern and what function it is. So this would be 2x squared minus 5x. And then take the derivative of that because it's just much easier that way. So this derivative would be 4x minus 5. And then we want to figure out what number to plug in, and it is 4. You just look at the pattern here. So we're going to plug in 4. 4 times 4 would be 16, minus 5 would be 11. All right, here, this is going to go to form 0 over 0 if you plug in 2. So this is going to be L'Hopital's rule. And so we're going to do the derivative of the numerator, derivative of the denominator. So derivative of the numerator, that would be 15x squared minus 1. Derivative of the denominator would be 1, and that's the whole idea, is that when you take the derivatives, you go down a degree, so the whole thing ends up being a little bit easier. And then you can go ahead and plug in 2. So 2 squared would be 4 times 15 would be 6. All right, and so for number 3, you're not plugging in infinity, but if you think about the numerator going to infinity and the denominator going to infinity, you're going to end up with infinity over infinity. So again, it's going to be L'Hopital's rule. So derivative of the numerator would be 2x, derivative of the denominator would be e to the x, and then you can take the derivatives again. So numerator would be 2, denominator would just be e to the x. You think about plugging in a really enormous number here, you're going to have 2 over a trillion, which is going to go to 0. If the denominator is growing exponentially, that's going to end up going to 0 because the denominator is growing so quickly. All right, number 4, find the second derivative at 5. So first, the first derivative of ln of x is 1 over x, and you can also write that as x to the negative 1. So when you go to do the second derivative, you bring the negative 1 down, and it drops to a negative 2. And so that would be negative 1 over x squared. And then when you plug in 5, you get negative 1/25. Right here, we're going to find the derivative at pi over 4. This is a chain rule. Your outside function is ln, and your inside function is cotangent. So outside function first. Derivative of ln is, well, it's 1 over x, but it's not just x there, it's cotangent of x. So it's 1 over whatever you've got. So 1 over cotangent of x. And then we're going to chain on the derivative of cotangent, which is negative cosecant squared. I'm just going to go ahead and put that in the numerator. And then we're going to plug in pi over 4. So I'm going to draw my triangle for pi over 4. Both sides are going to be root 2 over 2. And then we'll evaluate this. So negative cosecant squared. Cosecant is the reciprocal of sine, which is the y value. If you reciprocate this, you're just going to get square root of 2. If you flip square root of 2 over 2, it's just going to give you square root of 2. And then down here, cotangent is the x value over the y value. Anything over itself is 1. And so square root and squared cancel, and this is just going to give you negative 2. This, I'm really just testing you on the notation. This means first derivative, second derivative, third derivative. So first derivative would be e to the 4x, and then you have to chain on a 4. So 4e to the 4x. And then second derivative, it's going to be itself, but you have to chain on another 4. So it'll be 16e to the 4x. And then third derivative, same thing. It's going to be itself, and you have to multiply on another 4. So what is that, 64? Yeah, 64e to the 4x. All right, so first derivative, second derivative, third derivative. All right, number 7, use this function. We're going to have x be positive to find the derivative of the inverse at 1. So I'm going to make my tables for f and f prime, and then for the inverse and the inverse derivative. And we want to find the inverse derivative at 1. So since these are inverses, if it's the input over here, it's the output over here. And that allows us to set up a problem. We're going to set this function equal to 1. I'm just going to do this off to the side and then solve that. So add over the 15, divide by 2, cube root would be 2. So this point is 2, 1, this point is 1, 2, and now we're going to do the derivative. So the derivative of this function would be 6x squared, and I'm going to plug in 2 to that because we're working with function f. I don't have the inverse function, so we have to work with what we have. So plugging in 2. 2 squared is 4 times 6 would be 24, and you just reciprocate that for the inverse derivative. So 1/24. All right, over here are your chart problems. Average rate of change just means slope. So on the interval 2 to 4, we just have to go and find those points. Just make sure you look at the G column. 2 gives you 3, 4 gives you 2, and then you're going to do the slope. And you don't need to simplify it. You can leave it right like that. All right, equation, that means you need a point and a slope. And we want our point of tangent C to be 2, and we're looking at function f. So looking at the f column, the point is 2, 4. Derivative gives you the slope of the tangent line. That would be -1. So it'll be y minus 4 equals -1, x minus 2. All right, this is your product rule, so I'm going to write that out. It's first times derivative of the second plus second times derivative of the first. Now, don't link these with an equal sign. Just don't put anything if you don't have room to go down to the next line. So now we're going to go and plug in the actual numbers. So f of 1 is -1. G prime of 1 is 5. Plus G of 1 is 1/2. And f prime of 1 is 3. And again, you do not need to evaluate that. This is your quotient rule, all right? It is denominator times derivative of the numerator minus numerator times derivative of the denominator over the denominator squared. Again, don't link this with an equal sign. Just don't put anything. All right, G of 4 is 2. F prime of 4 is 4 minus f of 4 is -2. G prime of 4 is 7. And then G of 4 was 2, and that is squared. Again, you do not need to evaluate it, just leave it alone. And then this is your chain rule. So it's derivative of the outside, leave the inside alone. So f prime of G, and then chain on G prime. We're going to plug in 2. So G of 2 is 3. So this will be f prime of 3 times G prime of 2. F prime of 3 gives us 1. G prime of 2 gives us 4. All right, and then this is inverse derivative of f at -1. So again, I'm going to make my chart for f and f inverse. And we want to find this at -1. Again, these are going to be reversed since they're inverses. So you want to look at the f column, find a -1. It's the point 1, -1. And so this would be reversed. And f prime there is 3. And so this answer is 1/3. All right, and then finding all of these derivatives. Derivative of square root is 1/2 square root. So you're well off to just know that one. And there's a 7 there, so it'll be 7/2 square root. Now this, if you want to write it off to the side, it's really 2x to the -5th. And actually, it's also a -2 because it's being subtracted there. So if you do that derivative power rule, negatives are going to cancel. It'll be 10, and then this will drop to a -6. So it'll be 10/x to the 6th. This one is a chain rule. We're going to bring the 9 down. Everything inside of here is going to stay the same. It'll drop to an 8. And then we're going to chain on the derivative of this inside stuff. So 3x squared plus 4. All right, this one's a quotient rule. It will be the denominator times derivative of the numerator minus the numerator times derivative of the denominator over denominator squared. All right, this one's a chain rule. There's 3 links in the chain. So you're going to bring the 2 down, and it's going to drop to a 1. I usually put the 1 there so people can see that it dropped to a 1, because if you leave it blank, sometimes people forget that actually happens. So bring the 2 down, it drops to a 1. Now we're going to chain on the derivative of secant, which is secant tangent. So secant of 5x, tangent of 5x, run out of root here. And then chain on the derivative of 5x, which is 5. All right, this one is a product rule. So it is the first thing, which is the x to the fourth, times derivative of the second. Again, derivative of secant is secant tangent, plus the second thing times derivative of the first. So there's your product rule. You know what, I'm going to move down a little bit for this one so I make sure I have enough room. All right, cosecant to the fifth. So we're going to bring the 5 down. It's going to drop to a 4. And then we're going to chain on the derivative of cosecant, which is negative cosecant cotangent. So that takes care of this first part. We brought the 5 down, it dropped to a 4. And then we chained on the derivative of cosecant. All right, minus derivative of cotangent is negative cosecant squared. So the negatives are going to cancel. Cosecant squared of 5x. And then chain on the derivative of 5x, which is 5. So this is 2 separate terms here. So I did this derivative, got all of this, and then separately I had this derivative. Negative canceled, that's why this ended up being a positive instead of a negative. All right, arctangent derivative is 1 over, it's x squared plus 1, but we don't have an x here, we have a 5x, so I'm gonna have to square that. So 25x squared plus 1. And then you have to chain on the derivative of 5x, which would be 5. And I'm just going to go ahead and put that in the numerator. All right, so now we have particle motion, all our velocity and acceleration. We're going to use this position equation. We have feet and we have seconds. So make sure you put units for all of these. Find position, velocity, and acceleration at 3. Right, so position at time 3. 3 cubed would be 27. Minus 12 times 3 would be 36. What is that? Negative 9 feet. It's okay for that to be negative. It means that your object is starting out to the left of center. All right, and then we need to get the velocity equation. That's the derivative. That'll be 3t squared minus 12. And again, we're plugging in 3 for all these. So velocity at 3. 3 squared would be 9 times 3 is 27. Minus 12 would give you 15, and this is feet per second. So position is just feet, velocity is feet per second. And then the acceleration function, derivative of velocity, that's 6t. And then if you plug in 3, you're going to get 18. It's a rate of change. So it's feet per second, or feet per second squared. All right, what values does the particle change direction? In order to change direction, it has to stop. So we're going to set velocity equal to 0. So here's our velocity, 3t squared minus 12. Set that equal to 0, and we're going to solve. So add over the 12, divide by 3, square root. You would get plus and minus 2, but you can't have negative times. So just 2 seconds. All right, over what time intervals is the particle slowing down? You have to look at both velocity and acceleration. So what I usually do is make a number line, put velocity on the top, acceleration on the bottom. We just set velocity equal to 0, and we found that that was 2. So let's try and plug in a number smaller than 2, like 1. So if you plug 1 into velocity, you're going to have 3 minus 12, which is negative. If you plug in something bigger, we already plugged in 3 and we got 15, that's going to be positive. So it does change direction there. It's what we answered in question 22. It was moving in the negative direction and then in the positive direction. So like to the left and then to the right. All right, acceleration, 6t. That's only going to have a change at 0. Any number above 0 that you plug in there is going to be positive. So it's positive all the time. So slowing down is when these are opposite signs. So we would say from 0 to 2, it says justify. So because velocity and acceleration are opposite signs there. When does the particle move to the left and to the right? All right, so left would be when velocity is negative. So 0 to 2, it says justify. So because velocity is negative there. And to the right would be from 2 onwards. Time goes on forever here. We didn't have an interval where it was capped. All right, because velocity is positive there. So negative means moving to the left, positive means moving to the right. But you have to look at velocity. All right, find the distance traveled by the particle in the first 3 seconds. So we're going to look at where the particle is. That's position. So that's this original equation we were given here. In the first 3 seconds, so we're going to start at 0 and end with 3, but you also need to consider any time the particle turned around, which happened at 2. I get people that want to plug in every single number. You can do that, but you only need the starting, the ending, and when it turned around. So we're going to plug those into position, which is up here. If you plug in 0, you're going to get 0. If you plug in 2, 2 cubed is 8. So it'll be 8 minus 24, so negative 16. And then if you plug in 3, we already did that. We got negative 9. And then what I recommend doing is making a number line. If you can do it in your head, that's cool. I just always like to see it. So we're going to start at 0 and then move to negative 16. So it moves to the left. That's what we see in our table here. Moves to the left and then moves to the right. We go from negative 16 to negative 9. Then you can just see the motion a little better and add that all up. So from 0 to negative 16, it went 16 feet. From negative 16 to negative 9, that's a distance of 7. And so that's going to be 23 feet total. All right, so we're going to use this position equation for these next couple problems. Again, we have seconds and feet. At rest means velocity equals 0. So we have to get the velocity equation. It's going to be the derivative. So 60 squared minus 36c plus 30. And we can divide a 6 out of all of that. And then we're going to factor. So it'll be t minus 1, t minus 5. And so there's 2 times. We get time 1 second and time 5 seconds when the particle is at rest, which means not moving. All right, and then total distance in the first 8 seconds. So again, you want to plug into the position equation. We want to find where it actually is from 0 to 8. So we're going to plug in 0 and 8, and then you also want the 1 and the 5 when the particle stopped, because that's when it turned around. And again, I get people that will want to plug in 0, 1, 2, 3, 4, 5, 6, 7, 8. You don't need to plug in all of those, just the starting, the ending, and when it turned around. So if we plug into 0 here, we're going to get 9. And I am going to allow a calculator for this because I don't want you to have to do all this in your head. I'm not testing you on that. I'm testing you on, particle motion. If you plug in 1, let's see, it's going to be 2 minus 18 plus 30 plus 9. So 23. You plug in 5. 5 cubed is 125. Double that would be 250. All right, minus, what are we plugging in again here? 5 squared would be 25, so 18 times 25 will be 450. Plus 30 times 5 will be 150, and then plus 9. So let me add all that up. So negative 41, and then plugging in 8. Going to be 1024 minus 1152 plus 240 plus 9. And let me add all that up. So 121. Sorry, I didn't grab an actual calculator. I was just typing it in on the calculator on my phone. If you have an actual graphing calculator, you could do that all at once, not have to write it out like I did. All right, so again, I'm gonna make a table, or not a table, but like a number line for this. We're gonna start at 9 and then move to 23 and then move to negative 41 and then move to positive 121. And I like to draw that because it just helps see the motion. So I'm going to add all of that up. All right, so from 9 to 23, that would be a distance of 14. From 23 down to negative 41 would be a distance of 64. And then from negative 41 all the way up to 121 would be 162. So adding that all up, total distance is 240 feet. And then 28, is the particle moving in a positive or negative direction at time 4? Well, you want to find the velocity at 4. And actually, you don't need to find it exactly. You just need to know whether it's positive or negative. So let's see. You plug in 4 to velocity. 4 minus 1 would be positive. 4 minus 5 would be negative. So this is going to be negative, and so that means in a negative direction. So negative direction at time 4 seconds because v of 4 is negative. So again, if velocity is negative, it's moving in a negative direction. If velocity is positive, it's moving in a positive direction. All right, 29, here's our position equation. What times is the particle at rest? We want to set velocity equal to 0. So velocity would be the derivative. That would be 4t squared minus 16t minus 20. We're going to set that equal to 0. Everything will divide by 4. And then we're going to factor. So it will be t minus 5, t plus 1. So it'll just be time 5 seconds. That other factor would give us a time of -1, and we don't have negative time. So speeding up or slowing down at time 1, you need to look at velocity at 1 and acceleration at 1. You need to consider both. So velocity at 1, and you don't even need to figure out what it actually is, just whether it's positive or negative. If you plug in 1 to velocity, 1 minus 5 would be negative, 1 plus 1 would be positive. So that's going to be negative. A negative times a positive would be negative. And then we need to get the acceleration equation. So looking here at velocity, derivative of velocity, that would be 8t minus 16. And if we plug in 1, actually, again, I'm not going to figure it out exactly, just whether it's positive or negative. 8 minus 16 would be negative. So they're both negative, which means speeding up. If they're the same sign, it means speeding up. It's speeding up in the negative direction. So speeding up at time 1. Do we have, we weren't given units here. I guess I wrote seconds there, that's okay. Time 1, because velocity at 1 and acceleration 1 are the same sign. So same sign means speeding up, even if they're both negative. It means you're speeding up in the negative direction. All right, and then last one, we have this graph. It's the graph of velocity from times 0 to 10. Over what time intervals is a particle moving to the right justified? That's when velocity is positive, which would be above the x-axis, or I call it above sea level. So from 0 to 1, and then from 8 to 10, because velocity is positive there. And then speed decreasing, that means slowing down. Again, you need to look at velocity and acceleration. It goes from 0 to 10. You want to take any zeros or anytime the graph turns around. So we would want 1, 3, 5, 7, and 8. You can take every number, but those are the only ones you need. Actually, that's practically every number anyway. All right, velocity is positive from 0 to 1, and then negative all the way until 8, and then positive from 8 to 10. Acceleration is the derivative of velocity. So now we're looking at increasing and decreasing. So decreasing here, that means acceleration is negative from 1 to 3, positive from 3 to 5, negative from 5 to 7, and then positive from 7 to 10. Now this said speed decreasing, that means slowing down. Speed decreasing and slowing down means the same thing. That would be where these are opposite signs. So I'm going to say slowing down. I like that a little bit better. So slowing down from 0 to 1, 3 to 5, and 7 to 8, because velocity and acceleration are opposite signs there. And you have to say opposite signs. You can't just say opposite. It's that their signs are opposite.